Hello friends, I am Dr. Awdhesh Singh and I am going to take the classes for Physics class 11th. Today we are going to start the first lesson, that is physical world. In this lesson we learn what is science, what is scientific methods of investigation, what is physics, then what are the different type of forces of nature, and all these things we learn the basics of physics. So first let us know what is science. Science is made from a Latin word, this scientia, which means basically to know. That means to acquire the knowledge, to know about something, that is what is science. And in Hindi or Sanskrit we call it Vigyan. And in Arabic also it's called ilm. Ilm is also said to be knowledge. Let me now define science. Science is a systematic attempt to understand natural phenomena in as much depth as possible and use the knowledge so gained to predict, modify, or control phenomena. So what is the purpose of science? By science, first of all, we know the laws of nature. And then once we know the laws of the nature, then we try to see how we can take advantage of those laws. For example, let us say that you understand that the solar eclipse takes place because of a particular alignment of sun, moon and earth. So if we can know about the solar eclipse, then we can plan the things accordingly. Similarly, if we know the laws of physics, then we can accordingly predict, for example, weather forecasting. That is also something which is coming from the laws of physics, and if we know those predictions, then we can save ourselves. And so the purpose of the science is to collect the knowledge and then use that knowledge for the benefit of mankind. But science is one of the most misused term also. People will say that everything, they will say that this is scientific investigation. For example, they say that okay, if you take a hot water in the morning, then XYZ disease will go away. And they will say this is a scientific basis for it. But whether it is scientific, see, most of the people who tell something as a scientific investigation is actually not scientific. Because science requires a detailed elaboration. It requires a detailed method of investigation. Only when it satisfied those criteria, then only we can say a scientific investigation. Now, what are the different steps of scientific investigation? The first important step is the systematic observation. That means we are observing something and then we are going to draw the conclusion. For example, if the apple is dropping from a tree, then all the apples are dropping from the tree. So that is an observation. You observe something and then you find that this is a consistently done thing. No apple is going on the air, going up. So the second step of scientific investigation is called controlled experiment. That means find out how much time the apple takes to drop on earth, and that can be done by anybody anywhere in the world. So you are conducting experiment, you are noting the time and finding out how much time it takes to drop X length or X height. Then you do a quantitative and qualitative reasoning. This is very important. That you find out why this apple is dropping, why it is not going up. So that means there should be a force on the ground which is actually attracting the apple. So this is a reasoning which can be called a scientific reasoning. Then you do a mathematical modeling. What you do is that you find out as to, suppose the apple is dropped from 5 meter and then dropped from 10 meter, then dropped for 100 meter, and then you find out as to how much time it is taking. So you do a mathematical modeling and try to create a formula which will actually try to fit into all these observations. Then you make a prediction. You make a prediction that okay, based on this method, suppose I drop an apple from 7 meter height, then how much time it will take to come to the earth. And then if suppose it takes exactly the same time, then that means it is a true theory. It is a scientific method of investigation. But if I have given a formula, I open that formula to challenge by anybody in the world. So if I derive a formula, any XYZ can come and say, look, I dropped the apple from 7 meter, but it took much longer time. And if it can disapprove my theory, then my theory will be quashed. It will not be accepted as a scientific theory. So falsification and verification is also important. Once I have given a theory, anybody in the world can verify it, anybody in the world can falsify it. So this is very important step of scientific investigation. Now, the problem with the other type of investigation, other type of theories, that they are not open to scientific investigation. For example, if you say that yoga or X type of yoga cures cancer, and you can say that it's scientifically proven, Now, if you want that to be scientifically proven, then you have to say, okay, how many people did this yoga and then how much cure has taken place. This has to be repeated all over the country in different countries, different contexts, and then everybody should come to the same conclusion. If only that everybody come to the same conclusion, then only we can say it is a scientific investigation. As far as the scientific investigation is concerned, there are basically two types of fundamental concepts. The first concept is called unification. What is the unification concept of unification? Unification means that you are trying to explain the diverse physical phenomena in terms of a few concepts or a few laws. For example, the law which is responsible for attracting the apple to earth is the same law of gravitation which is used to define the movement of earth around the sun and also the movement of moon around earth. So you have derived a particular formula or you have derived a particular law, and that law is having a universal application. So that is what is unification. This is the first concept of unification. So the second important concept is called reductionism. Now what is reductionism? You see, when you have a macro observation, for example, you measure a temperature of a particular piece of iron or particular body, and let us say it is a 40-degree temperature, and then you measure a temperature of another body which is 80-degree temperature, and then if you connect that temperature at the lower level, for example, scientists have found that how this temperature is created, it is the measurement of the average kinetic energy of the molecule of the system. So they have measured the average kinetic energy and they found that the more is the average kinetic energy of the molecule, the higher is the temperature. And so they have been able to reduce the temperature to at the micro level. This is what is called reductionism. In terms of science, we should understand the meaning of three important terms. One is called a hypothesis. What is a hypothesis? Hypothesis is a supposition without assuming that it is true. That means you are supposing something, and when you are supposing something, you are not going to prove it. For example, when Newton said about the gravitational law, then he said that the forces between the two objects is inversely proportional to the distance square and proportional to the masses of the two objects. So now this is what he has presumed and he has created. He has not proven it. But when this was tested, it was found to be correct in every case. And that is why it is a valid hypothesis. So hypothesis is something you are not going to prove it, but if somebody disapproves, then it is rejected. So that is very important thing. The second important concept you have to understand is axiom. Now what is axiom? Axiom is something which is again something like a hypothesis, but it is self-evident truth. For example, Euclid has given this theory that two parallel lines will not meet. So suppose there are two parallel lines, they will never meet. And so he has not proven it. But we know from common sense that if there are two parallel lines, naturally the distance between the parallel lines is not going to reduce and therefore they are not going to meet. So it's a self-evident truth. So that is what is called axiom. And the third important thing is we should know about is model. What is model? When you observe something, then you try to convert that into some sort of physical understandable thing so that you can explain the observation. For example, Bohr has given an atomic model which was something like a solar system where in the center there was a nucleus which is positively charged and around that there were electrons which are orbiting. Now this is a hypothetical model, and this model has been able to explain the different phenomena and different behavior of the particular atom or particular material, and so it was accepted. So this was a model which was proposed by Bohr. So you understood that what is hypothesis and axiom and what is model. Now I would also like to explain you that there are basically four types of forces in the nature. There are different types of forces which are working and which are keeping the universe intact. The first important type of force is called gravitational force. Now this gravitational force is always attractive in nature and it is applicable for every material body. The gravitational force is responsible for movement of the stars, movement of the planets, and also we are standing on Earth because of the gravitational force. The second type of force is called electromagnetic force. Now electromagnetic force is actually coming from either electrical charge or from magnet. Now this force can be attractive as well as repulsive. If there is the same type of charge or same type of magnet, same poles of magnet, they repel each other, and if it is opposite, then they attract each other. So electric force or the magnetic force are basically both repulsive as well as attractive, and they also are infinite in nature, in the sense that they can travel any part of the universe. But the most important thing about the electric and magnetic forces are that they are integrated with each other. So if there is a charge which is an electric charge which is stationary, then it is giving you electric force. But suppose the electric charge start moving, then it also creates a magnetic field, and therefore the magnetic field and the electric fields are connected with each other, and these forces are also called electromagnetic force. These things we will discuss much in detail in the later chapters. The third type of very important force is called strong nuclear force. See, you have to understand that in the nucleus, which is a very small size, which is almost 10 to the power minus 15 meter of diameter, in that you have positively charged protons and the neutral neutrons. So logically these positive charges must repel each other and nuclear cannot stand. But there is another type of force which we call strong nuclear force, which is an attractive force, and it irrespective of the charge, whether it is a proton or neutral, it is attracted, but its area of application is only 10 to the power minus 15 meter. That is within the nucleus only it operates, but it's a very strong charge, almost 100 times more powerful than the electromagnetic force, and therefore it is able to overcome that electromagnetic force of repulsion and keep the nuclear together. So this is called strong nuclear force. The fourth important force is weak nuclear force, and this the force appears in the nuclear range only. It is even a smaller range of 10 to the power minus 16 meters, and this is responsible for beta decay, events like beta decay. This is the force which is lesser than the strong nuclear force, but it is much stronger than the electromagnetic or the gravitational force. Now finally we will talk about the law of conservation. Now these are also hypotheses. The hypothesis is that nothing in this universe is created and nothing is destroyed. So once it is created, it always remains in one form or another form. This is called the law of conservation. Now this is a hypothesis because you have not been able to prove it, but there has been no disapproval and nobody has falsified it, and nobody has been able to prove that a matter can be created from a non-matter or in random. Of course, matter can be created from energy and energy can be created from matter, but you cannot create either energy or matter from no existence or nothing. So these are the different type of conservation laws. These are the hypotheses. You have the conservation law of mass, conservation law of energy, conservation law of momentum, and conservation law of angular momentum and all that. And these conservation laws are used to prove different type of events in the world and also to solve many problems of physics. These laws of conservation are very important for physics, and if you know the law of conservation, then you can solve a lot of problems which are in the physical domain. So I hope that you have been able to understand the different concepts of the physical world, and this is just an introductory chapter. We will be dealing everything in much more larger details in the subsequent chapter. I hope that you have liked this lecture. Thank you very much for watching my video. Thank you very much.